So if you ever wondered what was inside the reduction gearbox on a Rotax engine, here's your chance to see one opened up. Now this is an RV12 and they are designed to actually have the wings be able to be removed by pulling a couple pins in the fuselage, and then the spar actually runs across behind the seats there, and the pins are actually on either side. You can see right there, and if you take those out, you disconnect the wings. So obviously the pitot mast could not be in the wing because of the connections and having to do a pitot-static check every time you did it. So in this case, they put the pitot mast in the center of the prop spinner. It's a unique solution to an issue, but it does make this setup a little different, because on many Rotax engines you'll find, I think, a vacuum pump or something like that mounted in this boss right, actually up here in this boss, and instead there's just an aluminum plug filling that, and I'll show you why in a second. But this right here is actually the end of the crankshaft. There's this nut, this gear. This is what drives the reduction gearing, which this is the housing right here, and that's the gear. So that crankshaft gear goes right here, drives this big ring gear here, which drives your propeller. So there's actually a pretty good, I'd have to count the teeth to tell you what the reduction ratio is, but it's at least half, if not more. This gear right here is firmly connected. It does not turn independent of this big prop gear. That would be the one to drive the vacuum pump or whatever pump it is that goes there. I believe it's a vacuum pump. I have seen it on some aircraft. In this case, this gear is doing nothing. It's just there. But there's your prop shaft. You can see prop shaft turning in sync with it. This is your crankshaft right here. That extra piece right there goes into the bushing right there in the housing, and you get your reduction. And the whole reason why is because the Rotax, just like pretty much any automotive engine, turns at an RPM that is too high for a propeller to deal with. So these are the blades right here, and what you have to remember is if the hub is doing, you know, the RPM of an engine, which I'm trying to remember because I've run this thing up before, and I want to say it's anywhere 3,000 to 5,000 RPM at full power. The prop tips, because of that arm, are going to be going so fast they'll be breaking the speed of sound, which just wastes a whole bunch of noise, causes a lot of vibration. It doesn't give you anything. Pretty much, depending on the span of your blade, the faster you turn it, you're going to get the tip going supersonic if you don't gear the engine down or just make a slower turning engine. I know the Cessna 206, if you ever listen to any of those on takeoff at full throttle, those prop tips are going supersonic. They turn close to 3,000 RPM. And Cessna did that because they discovered that the float version of the 206 got onto step, which is when the hulls actually start to plane, and so they're only riding on the very front of the float. It got on step a little bit faster, which shortens your run on the water, because once you're up on step, you accelerate a lot more and can fly away. So they set the aircraft to have prop tips that go supersonic at full throttle on purpose, and you can hear it with the 206. You won't hear it with too many other types of aircraft. And the interesting thing is the way these blades are retained. Notice that wider spot, there's a phenolic block that goes over that. And this is a ground adjustable propeller. It's not a constant speed propeller. So here's your actual prop hub. There's the spinner bulkhead and everything. That's what bolts on. And then this front plate literally is just bolted on, and on the ground you can turn these props And I am not seeing, so maybe you would actually, I haven't worked on this enough to know, you may have to, no, they look like they're pinned together. Okay, so the two blades are connected, so as you turn one, the other one turns, I believe. I'm gonna have to check that because I didn't take this apart and I haven't looked in the manual yet. I have worked on another propeller actually where I had to set, it was a 3-bladed one, and I had to set each propeller with a protractor on the ground because we were chasing an issue with RPM not being high enough. But these two pieces clamp down on those blades, and that is what holds your prop in place. Now, of course, that is different from a variable pitch propeller, or what's called a constant speed. And the constant speed, of course, has a governor and uses oil pressure coming through the prop shaft to keep the propeller in a range so that it hits a constant RPM based on the prop control that you are controlling in the cockpit, which changes the weight, the preload essentially against the flyweights inside the governor. And if you don't understand that, look it up. But this is the low-tech earlier, you know, actually aircraft had ground adjustable propellers before they were constant speed propellers, which was an upgrade from fixed pitch propellers, which are just a solid block of wood, or these days aluminum, which is set at the factory, and that's the only RPM it's ever going to do. The reason for a ground adjustable is, let's say you're doing a long cross-country trip, like the owner of this aircraft actually flew it out to Burning Man from up here in New England. That's a long trip. He could actually set that for a better cruise efficiency, which is slightly higher torque, and therefore get longer legs in the air, but his takeoff performance won't be as good because the propeller will be trying to bite too much all the time. Whereas, let's say he lived at high elevation, maybe he's going to want to set it to a climb, like if he lived in Colorado or something, to help him get up off the runway sooner in the air that's thinner. Or just normally you can kind of play with it and figure out, do I want to have a prop that allows me to climb faster, or one that is more efficient in cruise or faster in cruise. There's variables, and a few degrees here and there can give you that. But there you go. Gear reduction in a Rotax. Gear reductions are pretty unusual in GA aircraft. The only ones that I can think of right off the top of my head are on the Cessna 421, which is a GTSIO 520. And those actually have a similar setup where the crankshaft literally has just a gear on the end, and then there's a second gear which doesn't look to me to be as large diameter difference between this gear and that gear, but obviously they wouldn't be one-to-one, or there'd be no point for it. And that is also to have the same idea, same reason, that the propeller turns at a slower speed than the engine, because they found that with the turbocharged engine and heat that's generated and all the things that go on with that, running the engine at a higher RPM and the propeller at a lower RPM gave the aircraft more efficiency. And if you ever want to be able to tell a 414 from a 421, they have the oval windows, they have the air stair door in the back, so they're pretty much the Cessna twins from the 320, 340, 401, 402, 414, 421. But the 421 cowling will have a humpback, will have a bump running down the middle, and that's for the gear reduction on the propeller. And the whole reason that any direct drive, now this is a fixed pitch propeller, as I was telling you about, this is just a solid piece of aluminum all the way across, and typical Lycoming engine, your maximum RPM of the engine is going to be low enough that these prop tips with that span will not break the speed of sound. The way they do that, and people always look at these engines and go, they're so low tech, you know, The pistons are very large diameter compared to your car, and they turn at a very low RPM. You know, these idle at 1,000. You usually can pull them all the way back to 600 or 700 RPM, some even lower, some a little bit higher than that. And at full throttle, you're 25, 26 maximum RPM, 2600, somewhere in that range. As I said, with the 206, they push over 3,000 RPM on, depending on which aircraft you're talking about, which model, serial number, all those kind of things, what engine is in it. With the 520 usually and they did that just to give it extra get up and go on the ground. But this one, it makes no sense to do that, so they kept these designs. Yes, they're from the 1950s. Continental is the same, but they work because they're nice and slow, they turn on nice and easy, and that's gear reduction. And the weight of it, the complexity, like that gear reduction we just had to take apart there on the RV, was because the chip plug was a magnetic plug in the bottom of the box for the reduction gearbox was all fuzzy, which means the teeth were wearing. This, you're not going to have that because there's no teeth to wear. The only place you're going to get issues in here is, let's say, your camshaft and your cam followers, which do the push rods, tappets. Lycomers are notorious. If you leave them plugged in all the time, boils the water out of the oil. The water goes to the top of the engine. Top of the engine's cold. It condenses. You get water on the tappet bodies, and that causes rust pits because they are made out of steel. And every time that camshaft comes around, it's just a flat face. There's no roller tappets. That rust pit takes a bite out of the camshaft, and I have down a number of aircraft over my 30 years as an airplane mechanic, because when I cut the filter open, it looked like someone just dumped handfuls of glitter into the filter medium, and that was from the tappet just eating the camshaft, usually multiple tappets. And you pull the cylinders off, you go start looking up with a flashlight, and yep, look at that, there it is, you can see it. And it will even have eaten, it almost looks like tree rings into the camshaft. It's something about the way the outer surface has a different hardness maybe than the inside, for I don't know why, probably wear characteristics. And as it eats through those layers, it'll almost look like it left rings on the camshaft, like tree rings. It's an interesting thing to see. I haven't seen it in years, unfortunately. I have some pictures. Cell phones didn't exist the last time I saw one, and I had to down it for it. That's just how long ago it was. So the oil filter will be the thing that lets you know that this is making metal, whereas on the reduction gearbox, it's a little magnetic plug, kind of like gearboxes in helicopters and turbine engines and things like that. Okay, so I figured out how these ground adjustables work. Notice there's a pin right there in the end of the blade, and as you turn one side, there's this plastic piece that is going to rotate, and that's going to adjust the blade on the other side to keep them fairly synced and pitched, so you don't get a massive imbalance in vibration. And the bottom of this plastic piece locks in to that aluminum piece right there. Gives it some adjustment, but obviously you can't go ridiculous with these props, or you're just gonna over torque or give them not enough pitch to make any thrust.